Well, hello everyone, and thank you for joining us today for our safety webinar called the 10 Frequently Asked Questions During Our CMET Motor Schools. Whether you're a 20-year veteran in the entertainment industry or just a rookie rigger, there's always something to learn about the use, inspection, and safety precautions involved in entertainment lifting applications. In this webinar, we'll review some of the most frequently asked questions during our CMET motor schools, ranging from lifting speeds and sling use to inspections. My name is Gisela Clark. I am the e-marketing specialist at Columbus McKinnon and will be your host for today's webinar. Presenting today will be Dave Carmack, our CM entertainment trainer. He's been with Columbus McKinnon for 37 years, very hard to believe. Dave has taught motor schools in 6 of the 7 continents. Also on the call today is our guest speaker, Eric Rouse. He's the technical director of the Denver Center for the Performing Arts. Eric was the head of rigging maintenance for Cirque du Soleil's show O at the Bellagio. Both Dave and Eric are ETCP recognized trainers and instruct regularly for our CM Entertainment Mega School. This is a unique opportunity to bring these 2 trainers together virtually, and I'm very excited about it, as I hope you are too. We will be recording the session today, and the recording link will be added to our YouTube channel. All in attendance will receive a link to the recording. Everyone is in listen-only mode, so we encourage you to ask questions in the Q&A pane on the right side of your page. We'll take 5 minutes at the end to answer questions, and again, like I said earlier, those that don't get answered will be addressed in our Twitter chat at 12. We'll talk more about that at the end. As a side note, after each webinar, we select a few questions to be used in our blog the following week. If your question is chosen, we're going to send you a CMET external battery pack from Dave Carmack here himself. So please ask the questions. We're going to take 2 for future blogs. So everyone, thank you for your attention. We just want to share this disclaimer quick if you'd like to take a quick look. This information training is intended for general information purposes only. And if you can take a quick look at that, and then we'll move on. Okay, Christy? All right, so how we're going to do this today, we've got 10 questions, and I'm going to kind of launch them to each David and Eric, and we'll let them take them away. So we're going to start today with Eric Rouse on question 1. So Eric, is there one correct way to wrap a polyester or steel round sling around a truss?
So I guess let's go to the next slide. And no, there are several ways to wrap truss with a sling. And the thing is that as long as it's safe, use the preferred method by the house that you're working in. This is always a big source of arguments on calls, so I thought this was a good one to start with. If you go to the next slide, this is a pretty typical wrap that we do for truss. But what you'll notice is that there's 2 different types of wraps here. That's what generally is the discussion. We generally start, if you go to the next slide, please, with a choke down at the bottom of the truss, the bottom core of the truss. In our industry, we try to do the lifting on truss from the bottom core of the truss. It's just so you know, it's not absolutely necessary every single time, and that does vary by manufacturer, but that is something that we've done generally as a rule in our industry. So this is what we look at the bottom, what we call a choke, and then if you go to the next slide, this is one version of how we wrap the top cord of the truss. This is what we call a choke on the top cord of truss, and I'll come back to this in a second. Go to the next slide. We would call this a wrap on the top cord of the truss. Now, there are some houses that prefer the choke, and there are some houses that prefer the wrap. They're both fine. They're both okay. There's just something that you need to realize if you're doing, go back 1 slide, please. If you're doing the choke, that there's a chance that the tension there can be more tension on that top cord, and that the load is not transferred to the legs that go between the choke on the top and the choke on the bottom. So as that type of choke is getting tension, you want to make sure that you manage it and make sure that that choke is rolling and that the tension is getting transferred. Go back to the next slide, please. On the wrap, that's not as much of an issue because just having that single half wrap, it tends to roll easier. I tend to do the choke because frankly, I just think it looks better, and sometimes sexier is important in our business, so that's what I do. If you go to the next slide, this is the finished product, so that's what it should look like. So either one of those is fine. If you're working somewhere and you tend to do it one way and they say no, do it this way, do it that way. It's not unsafe. There's no reason to have the argument about it. Next slide. Next slide, please. Great. One thing that I wanted to mention is you don't want to choke polyester or steel round slings together. There's a pretty serious derating that happens in their strength that's been documented, so you don't want to do that. If you need to connect them for some reason, you're going to want to use a shackle or something like that. You want to make sure that you have the slings next to a spreader on the truss. Those are the pieces of pipe or tubing, sorry, that give the truss its spacing. You want to try to stay away from the welds as best you can. You know, the load charts are all based off the weakest point in the truss, the weakest point in the truss being the weld. So, you know, sometimes you can't avoid it, but you want to try and do your best if you can. And don't use slings that are too short. And the reason for that, if you go to the next slide. Go to the next slide, please. Is because you'll notice as you change angles, as you wrap around a truss, the tension on the legs of that polyester or steel round sling changes dramatically. If you have a 60-degree angle, you'll notice for a 1,000-pound load, if these lines were parallel, you would have 500 pounds on each side, on each part of the sling. But since we put an angle in it, that load increases. So at 60 degrees, you get about 78 pounds extra on each leg. At 45 degrees or 90 degrees at the top, you end up with a 200 pounds extra. And then once you have that really shallow angle, which we see a lot in like ballrooms and situations where you have low head height, you're putting an extreme amount of tension on those legs. So you end up essentially doubling whatever that span set is, whatever that round sling is holding. So that's one reason why we want to make sure that those slings are of the correct length. I think that's it.
Okay, okay. Question 2. Thank you, Eric. Excellent. This one I'm going to direct at Dave. Dave, when hanging a CM motor, do you add the motor and chain weight to the capacity of the motor?
Usually when I get asked this question, there's a lot of variables that I have to kind of decipher out. One of them is where am I measuring the load point? Also, am I going to be using the motor in the motor up position or the motor down position? So if you kind of go to the next slide, you can kind of see here now. If you're letting the line be your pick point or your rigging, in this case here, yes, I would. You do add the weight of the motor as well as the chain and the chain bags and all that stuff. Now go on to the next slide. Okay, with this one, we're actually looking at the capacity that we're actually putting on the motor, not the pick point. In this case, the motor itself is in what chain is in the chain bag is not an issue. It's just the load that's on the hook as well as the load chain that's seeing the tension. Now, if you turn the motor over and use it in a motor down position like it shows on the next slide, you can kind of see now that the load hook itself is not part of the load. Again, we're just measuring the capacity that we're that we're putting on that the motor sees. And in this case here, the load hook and the load chain that's supporting the load is not a factor. Only the motor and the weight of the chain that's in the chain bag. And I guess that's the answer to that question.
Okay, Eric. So this one I'm going to direct at you. What is the difference between weight load limit, safe working load, and braking strength?
Yeah, if we could go to the answer slide. The weight load limit and safe working load, they're basically the same thing. The preferred term now, and it's been this way for several years, is weight load limit, and that's what's stamped on most hardware like shackles and things like that. Safe working load fell out of favor a while ago because of it connotated some assumed safety, and you can't guarantee that every time. So the term switched to weight load limit, and weight load limit is a predetermined fraction of the braking strength. So the first thing that we want to know is that the braking strength is basically what the hardware should brake at, and that weight load limit is going to be a fraction of that. And the fraction of that varies by manufacturer and by industry, or not by industry, by where it's manufactured, by manufacturer, etc. Next slide, please. So if we look at a CM shackle and we look at the specifications for it, usually the ones we use in theatrical and arena rigging, you're looking at a 1/4 inch, 3/8, 1/2 inch, 5/8, 3/4 inch shackle. They have a certain weight load limit that's stamped on the side. There's certain regulations that say you have to, or standards that say you have to have certain information stamped on these shackles, and the weight load limit is one of them. So if you look at a 5/8 inch shackle, you see, or let's go with 1/2 inch because the math is easier. You see that the weight load limit is, or working load limit is 3 tons. Well, the the thing that's interesting is that, well, we want to know, well, what would it actually break at? If you look at the literature there next to the shackle, it says that the design factor is 6 to 1. So that means that in theory that this shackle should break at 6 times what that working load limit is. And that's how we look at the difference between breaking strength and weight load limit or working load limit. Another interesting thing about shackles, if you go to the next slide, please. Next slide, thank you. Is that depending on how you use them or how the shackles end up getting configured in your rigging, they may need to get derated. So, for example, if you're looking at a shackle that's potentially side-loaded, for example, not going in the long line of the axis of the shackle, but on the short axis, you could end up with what we would call a derating factor of 50%. So you would only have about 50% of your working load limit or weight load limit for that shackle. So we want to always avoid side-loading shackles. But if you do have a side-loaded shackle in a particular situation, you could look and see, okay, my working load limit is this much, so I'm still good for 50% of that. You're still going to want to fix it. I'm not saying to leave it there, but it may not be cause to panic. Another thing that's interesting about shackles is that they do have a certain working angle, and for most shackles, that angle is 120 degrees, or all screw pin anchor shackles, I think, is 120 degrees. So if you look at the bottom picture there, you don't want to exceed that 120-degree angle. So yeah, as long as you stay within that 120-degree angle, you have the full working load limit or weight load limit of that shackle. If you go past that, then you need to derate it. I think that's that.
Excellent. Thank you, Eric. And just so you know, a lot of questions have been coming in, and I'm trying to respond, just letting you all know that we are going to be taking all the questions at the end. So keep typing them in. We appreciate them very much. Okay. All right. Question 4. This is yours, Dave. What would cause a hoist to have different lifting speeds?
This is one of the big questions that I get asked a lot. Each situation is kind of independent than the other, and you kind of have to research it out because there's so many different things that would cause this. But the most common thing it is the voltage and load. The load does have a direct effect to the lifting speeds. In my classes, I kind of talk about the type stators that we use, the type stators that's used in a hoisting application. We have to find a fine line between performing and overheating, but the type stators that we use, because of this, it doesn't have constant lifting speed. So if one motor is seeing a lot more than the other motor, we're going to have some lifting speed differences. Other things that would cause it would be the clutch is slipping out trying to lift the load. And also the brake adjustment. We have a brake adjustment recommendation on our classic Lodestars to be between 25 thousandths of an inch and 45 thousandths of an inch. And if the brake is too tight, then we're going to be driving through the brake, and the motor doesn't know the difference in a really heavy load or the brake is just too tight. It just knows that it's really difficult to kind of drag through. Go on to the next slide, you kind of see what we're kind of talking about as far as the difference in the lifting speeds. Again, if you're looking at small variables, yes, then that is. But if you're looking for something large like 3 feet per minute, then we've got other issues that's going on. It really needs to go back and be looked at. But just most commonly, it's usually voltage and load is the cause of it. Okay, that's got that one.
Okay, perfect. All right, question 5. This one's for you, Eric. Are dynamic forces a factor to consider when designing or rigging?
Absolutely. And actually, if we could go back a slide, back to Dave's graphic of the hoists. Yeah, go back one more. Great. If you look at these two hoists, they're running at 2 very different speeds, and the dynamic forces that would be created with these 2 different speed hoists would be extremely different. So actually, this is a very pertinent question to our industry because there are 16 foot per minute hoists, 32 foot per minute hoists, and also high speed hoists, which are a completely different ballgame and not really part of this conversation at this point. But so this is really pertinent. So go ahead to the next slide, please. Great. So yeah, we want to take them into consideration. Sometimes forces can increase by 50% or more, depending on how rapidly objects start and stop. Now I looked at the attendee list and I saw that there were a couple people that do acrobatic rigging. So the second I said 50%, I'm sure they kind of laughed a little bit. You know, they're looking at force that can exceed that dramatically. And there are some situations in the entertainment industry where we can exceed that as well. For hoists, you know, usually 50% is a pretty decent number, depending on how you use it. Dynamic force produces an acceleration on acceleration of an object, and the amount of dynamic force will vary based on the time it takes for the object to ramp up to full speed or ramp down to zero. So what we have to remember about hoists especially is that they're not a soft start, soft stop type of machine. They're an awesome machine, but they're instantly on and instantly off. And that instant on and instant off creates a small, I'll call it a shock load, though it's not really a shock load, a small shock load on the system. And that little shock at the starting and stopping does produce an overage of some sort. And that overage can get transferred to the rigging. One thing that's interesting to think about then is that if you're at a certain design factor for a static calculation, let's say you're figuring out some points for an arena show, and you know that every point is going to be, or these points are going to be 2,000 pounds. That's what your limit's going to be on those points, and it kind of has to be if you're using a 1-ton motor. Then something that a lot of people just don't think about is, well, the load has to get up there somehow. And as you're pressing the pickle on the hoist controller to get the hoist up and down and getting things into place, that you are increasing your load a little bit. So maybe you should back down your top numbers, your load numbers a little bit, and give a little room for those potential dynamic forces that are absolutely always going to be a part of what we do. The stuff doesn't get up there by magic. The stuff gets up there mechanically, so the dynamic forces are going to be an issue. I think that's that.
Fantastic. Okay. All right, Dave, this one's for you. So just one second. Hang on. So if someone does not have the time to do a full inspection, what is the most important part of a hoist that needs to be looked at? I'll bet this is a question you hear an awful lot.
It is. This is, it spawns off of whenever you do a full-blown inspection, like we recommend, it does take some time. And a lot of times time is something that we don't have a lot of. So when I get this question, I answer it, in the official CM way and says, really, there is no one part more important than the other. It takes every component inside of it, fasteners and everything, to actually make that motor safe. But I do understand this and about the time restrictions and stuff. But if I had to personally pick one, I would think that the chain, where it is handled the most, it's used the most, it travels across the lift wheel, like you guys had already talked about the dynamic forces and stuff that's going on in between each individual links. I think the chain, in my opinion, would be considered maybe the most important. But again, I stress to you, don't shortcut any kind of a safety inspection. If you've ever attended one of my classes, you see that I teach to play CSI. When you take the cover off the motor, the cracks, damages are not going to jump out at you and say, hey, here I am. You have to actually go in and look. So if you shortcut an inspection, you could probably be going over something that really needs to be checked out or replaced. But in the official answer would be, really, there is no one part more important than the other, but I would really pay attention to my load chain.
Excellent. Yeah, we have a lot of blog articles about several of these things. And yeah. Okay. Question 7, Eric. If we know that our points are able to handle the loads, why should we calculate tensions in our bridles?
So this is always an interesting conversation when I do my seminars, because people get a little confused sometimes. And, well, I don't know, maybe that means I'm not teaching it well. But even though we know that a point is suitable for the load we're lifting, depending on how we are lifting it, there are certain things that we need to consider. And knowing the load is only half the battle. Knowing the load and knowing that the hoist can pick it up and that the point can support the load is really only part of the story. We also need to know, sorry, I lost my screen here a second. Here we go. We also need to know that our hardware and cable is being used within their working load limits at the angle that it is being used. So I'm going to go to the next slide, which is actually a repeat of a slide we looked at earlier. And basically all we have to do, if we're assuming an arena type of situation where we're doing bridles, we just need to take this and kind of flip it upside down if I'm talking about the top, right? Let's assume that that truss is two different steel I-beams up in the roof structure, and then we're coming down from that roof structure and going to our bridle point, which would be the bridle junction, which would be the shackle and then the hoist. Well, what I said before, right, is if we have a, excuse me, a 1,000-pound load, well, because we've put an angle into the situation here, the tensions on those bridle legs are going to change, and they can change pretty dramatically. So it's really important to see that, well, even though I'm only putting 2,000 pounds on this, and that's well within a standard 5-to-1 design factor, that if you have an angle that's fairly drastic, for example, if you go to the end picture and you see that we have a bridle junction that is 120 degrees, well, we have now taken that 2,000-pound load and created 4,000 pounds of tension, right, sharing 2,000 pounds on each side. So it's really important to do the math, or do whatever calculations you do. There's a few methods to do it, to determine what that tension is in those bridle legs, because depending on the angle that you're at, you can severely increase the amount of tension that you're putting on those legs. So we want to figure out what our load is to understand that we're not overstressing the hoist, the truss, the supporting structure, but we also want to do our tension calculations to make sure that we're not overstressing the hardware and the cable slings that we're using to create the point. So I think that should help clarify that. Oh, and then yeah, a little simple guide I use, thank you for going ahead, is that we try to stay within 60 degrees, 45 degrees. Those are ones that we like, or 90 degrees. And people always say, well, I don't have a protractor to carry around, or how am I going to figure that out? Well, your hand can be used as a protractor, right? If you do a peace sign, you'd actually have to spread your fingers a little more than the guy in the picture there. You could guesstimate 60 degrees. If you do the little shaka sign, you can basically rough 120 degrees to know if you're a little past, where your 90 degrees would be. And 90 degrees, just put your L on your left hand there. And that's a good guide for 90 degrees. So if you can use your hand as a protractor, you can kind of know if you're in a safe zone. We want to stay away from the 120 degrees as much as we can.
I like those visuals, Eric. That was good. All right, question 8. Let's direct this one over at Dave again. Will a CM motor operate safely on a power supply different than a nominal voltage of 233/60?
Okay, I'll kind of answer this question with another question. All of us has actually hung a motor up in the air, and we've actually connected to a power source. How often do we ever hang a motor in the air and connect it directly to a power source, not an extension cord? So whenever you get into extension cords, you get resistance and all this stuff, and you start having voltage drops. So if your motor is rated for 230 volts, then of course we are probably hardly ever going to supply that motor with that 230 volts. So all motor manufacturers actually design their motors to run off of what we call an acceptable range. In the event, if you go on to the next slide, on the industrial side, these are the voltages, the most common voltages that we have at CMCO, both industrial as well as entertainment. For the entertainment, the nominal voltage of 230 volts, 360, any voltage in between the 208 up to 240, the motor will run without any problems. And you can actually go off of that plus or minus 10% of these voltages and still not cause a problem. Below that or over that, we start having overheating issues or under voltage issues, and the motor's not going to operate properly. But basically, because of the low voltage is really a way of life out in our market, then of course our motors runs off at different voltages. Okay.
And David, I have a question for you.
Yes.
Is brake chatter? Does brake chatter work into this? Because I hear a lot of people when they say they hear the brake chatter that they think the voltage isn't right on going into the hoist.
Yeah, absolutely. The brake chatter is one of the biggest things that will tell us that we're supplying not supplying the motor with the right amount of voltage. You have a sine wave that creating a pulse in itself, and so voltage going into a lot of copper wire wrapped around a steel object, that's just the magnet. So if I'm putting the right voltage into that magnet, then that magnet is strong enough to overcome the opposing force. In the brake, it's actually the springs that wants to keep the brake closed. But when we're supplying a lower voltage into the brake coil, then of course the strength of the magnet is actually lower. The opposing force or the springs doesn't change. So what we're starting to hear out of that chatter is actually the brake going open and closed within that sine wave. So brake chatter is really a great indicator that I'm not supplying the motor with the right voltage. That's a great question, Eric.
Thanks, man.
Okay, Christy. Let's see. All right, this is back to Eric then. Question number 9. Can a CM motor be used at an angle?
Well, and I'd like Dave to chime into this one too, because I actually did ask Dave to send the graphic for it. But yeah, as long as the motor body is able to follow the angle of the chain properly, you can use it that way. You know, back in the day, you don't really see this much anymore, but back in the day, people used to do angled dead hangs with hoists or make bridles out of hoists and adjust the hoist to do bridles, and you still see that a little bit. But and so in that case, those hoists are being used at an angle. Where you can't do this is if the motor chain is coming at an angle and the motor body isn't allowed to follow it. Then you're going to start. What would you start damaging if we start doing that, Dave?
Well, the pulling the chain off at an angle, and it's let me back up and add this to it, that it's really load dependent. Because if you look at this slide that we have in front of us, the motor's in like a 90 degree, and then the chain's coming off at an angle. If the motor was being connected to a pivot point, when I apply the load, then the motor itself is going to straighten up, and then I'm going to have a straight line between upper hook and lower hook. Where we get in trouble is we may try to connect our motor in a fashion that the motor itself can't rotate. And the chain is guided into the motor by hardened chain guides. And the chain guides is really actually heat treated harder than the chain. And because if it wasn't, then the chain would kind of push it out of the way. The purpose of the chain is to make sure that the chain stays in the pocket. Newton says for every action, there's an equal reaction. So as the load's being pulled down on one side, the backside of the chain or the backside of the lift wheel wants to ride out. So that's the purpose of the chain guides. So that in order for the chain guides to do its job, they have to be heat treated harder. Now I've got a piece of chain that is probably the most expensive part of the motor going into the motor at an angle, dragging it across a part that is harder and could do damage to. We could actually start destroying our chain. If not, I mean, it will destroy the chain, but it'll also start rolling burrs over on the chain guides. It's just going to magnify the problem. Did that help?
Right. And one of the things that I see most typically that's not done with hoists is lubricating the chain. So if the chain's not lubricated, that makes that even just awful.
Absolutely.
Much worse.
Absolutely. I teach in my classes that I've heard all the stories because, lubricating the chain is, it's difficult, it's time consuming, and it's messy. But I've heard all the excuses not to do it. And honestly, in my 37 years, if you have seen some of the things that I've seen, but unlubricated chain, and the argument couldn't be had.
That's a good point. All right. Question 10, last but not least. And this is, I'm going to direct this at both of you too. So what are the D8, D8 Plus, and C1 standards? Maybe Dave, you can start the conversation, and Eric, you can chime in.
Okay. We get asked this a lot. This is really a recognized code of practice that's going on over in Europe. And what they do over there, their standards requires motors to be set in certain classifications based off of how much safety that we build into it or how much redundancy that's put into it. The slide showing here is the SQP2 2010. If you want to, you can go to the website and or Google that, and you'll actually pull it up, and you see that pretty much telling you the same thing. But over in Europe, if you can go to the next slide. Over in Europe, they kind of break their motors down into 3 classes: the D8, D8 Plus, and C1. And again, based on the design factors that's in it is where they put them. A D8 is what we've been using for years and years and years. We actually designed the Lodestar in 1955, long before the D8 classifications, where what we've been building since then is a D8. It's got a 5-to-1 design factor, and it's got a single brake. In Europe, the way they do it is in order to suspend a load over a person, if your motor carries the D8 rating, then I have to have a secondary strap on that motor before anybody can get underneath it. Now, if I don't want to do that, I could invest into what we call a D8 plus. Basically, a D8 plus is a modified D8. With the D8 plus, it comes with a 10-to-1 design factor, and we add a separate brake. So the brake has two operational brakes. So in the event one brake goes out, the other can still support the load. With this one, you still can raise the load, and you can turn it off and disconnect power, and then people can come in under it without using that secondary strap because of that extra safety redundancy that's built into it. Now, if you want to get up to what I call the Cadillac in the market, which is a C1, as you can see, you got all of these additional things. You got your two separate brakes. You got 4 limit switches. 2 of them is the operational, and 2 of them is your emergency stop in the event that something happens to your first one. It's got load monitoring in it, and it's programmed to shut off if you accidentally apply a load of 120% of rated load. And it will shut down on if the load is accidentally removed. For instance, if you're loading in and you accidentally set one truss on top of another and your spotters didn't pick up on it, when the load goes off, it will send a signal down and the system will actually shut down. And of course, it also has the 10-to-1 design factor. With this one, you can actually fly loads over people, or you can lift loads over people, and you can actually fly loads. But still, again, whether it's in the U.S. or whether it's in the Europe, we still don't recommend that you actually fly people with the motor. But this is what we're talking about here is basically a European code of practice for of how they do their rigging.
Eric, would you like to go ahead and make a comment as well, or?
Yeah, sorry, I was talking and I was muted. The D8 Plus, Dave, you said it's a modified hoist. I mean, it is modified that it's got the 2 separate brakes, but in terms of increasing the safety factor, is that simply taking a 1-ton hoist and saying it's now a half-ton hoist, or taking a half-ton and saying it's now a quarter-ton?
That's the way we do it. We readjust the limit. I mean, the load protector to still reject the load, but if a 1-ton motor carries a 5-to-1 design factor, if we derate that to a half-ton motor, still the same body, still the same hook, still the same chain, that gives us the 10-to-1 design factor.
Right. And I think it's important to make sure that we remember the statement from the beginning is that these are European standards, and not to say that they're not going to come here at some point. They're not here yet, so the way we do things is a little different.
And that's
worth saying.
Isla and myself was talking before we started that this is really, you really need to work off of the standards of where you're at. Like I say, this is a European code of practice. We kind of have our own over here. If you want to go with the European code of practice, take it to the person who owns the liability of what you're doing and say, this exists. Do you want to go with that? That way, the person who owns liability accepts the liability, if there was to be any.
Yeah, that's a very interesting point that you brought up. We had an interesting conversation before the webinar started on a variety of things. It was nice. It's nice to be live here with Dave and ask him these things. Okay, we're going to go into question mode now. A lot of questions have come in. I'm hoping we have about 12 minutes. My goal is always to get you guys out of here at the time we promised, which is 11:45 our time. So we're going to go ahead and get started. Is there a specific style of sling for this application, or is any approved style of sling usable? Let's see.
So I'm assuming he was referring to the round slings we were using to lift the truss. Can we go back to the beginning of the presentation, to those first slides?
Let's see which slide that was. Can you see which one?
She's going back.
Would that be slide?
It's for question 1.
Yeah.
Yeah, that right there. I'm assuming he's referring to that. And what we typically use for that are what we call polyester round slings or steel core round slings. Polyester round slings used to be the preference back in the day, but AHJ's authorities having jurisdiction were a little concerned about fire. And fire is an issue with polyester because it basically just melts and falls apart. So we wanted to do something that would prevent that from happening or prevent failure if there was a fire. So we used to do a secondary suspension. If we use polyester round slings, we used to do a steel, or some places still do, use a steel cable that goes around to the main shackle to continue suspending the load in the event of a primary suspension failure. What we've done is we've moved to steel core round slings now, and there are several manufacturers. CM is one of them that produce these slings, and they're good to use for truss. They have a nice surface area, so you're not worried about crushing the tube on the truss. But generally, those are what we use: polyester round slings or steel core round slings for this application. And the steel slings now prevents the need of a secondary suspension because it is a steel product. It has an outer cover that's a fabric, but the inside is steel.
Okay, great, Eric. Thank you. The next question is catching the only two cords on the top with a basket okay? He might be referring to that same.
Right, I think he's referring to the same thing. So there's a yes and no there. So if what we're saying is if we're only grabbing the top cord, with most truss manufacturers, and I can't speak to all of them, but for most truss manufacturers, you can also grab from the top cords of the truss. For some manufacturers, you will still have the full rating, full chart rating for that truss. For example, I know that Thomas Truss, if you hang from the top cord, you will still have the full rating for that truss. There are other manufacturers that say if you are going to grab from the top cord that you need to derate your truss by 15%, 20%, so on and so forth. So yes, you can. But you need to look at the specific application and want to make sure with whoever truss you are purchasing or using for that application that they say that's okay, and if you need to derate it, how much you need to derate it.
Okay, great. Thank you. Take a look at that one. Let me just see. Okay, here is another one. So one of the big differences, let's see, this is what it says. One of the big differences between the standard Lodestar and the ET Lodestar is stator design. Are the hoists interchangeable in usage?
I don't know exactly what you're asking there. If we're talking classic Lodestars versus what we call the next generation, the one that we come out in 2010, they're not interchangeable. But as long as we're talking Lodestar, classic, or the version, then yes, of course, all the components are the same. At one time, and I tell people that really Columbus McKinnon did not get into the entertainment market. You guys got the Binair Industrial hoist that was painted orange, and you were buying it and you were painting it black yourself. So basically, in a nutshell, the motors are the same. It's just really the only difference is the color. Now, over a period of time, we've made a lot of changes, but whenever we make a change, then our engineers try to make everything to where they're retrofittable. So so I guess the answer to your question is yes, as long as it is a classic Lodestar or a next generation Lodestar, as long as you stay within that in that group, then they are retrofittable or interchangeable.
Okay, excellent. Thank you, Dave. All right, we're going to take a few more. Let's see.
Can I request which one we could answer?
Please, go right ahead, Eric.
Chris Peretti, I think that's how you pronounce his last name. I've seen his name around the business a lot, so I'd like to answer his. He says, he asked, what type of hoist action creates the largest dynamic shock load? Start up, start down, stop up, stop down. I've done this testing a little bit in the seminars that I do when I've been able to borrow load cells or use load cells wherever I'm doing it. And what I've noticed is that it does vary a little bit by how much weight you have on the truss, but for the most part, I found that stopping down, especially if you're doing it and bumping it a few times, that stopping down is really the biggest one. It makes sense, especially if you have heavy loads, because the brake is trying to stop that heavy load really quickly. And the more you push that button, and you're not supposed to do this, obviously, but the more you push that button and the more rhythmic you make that, the higher your shock loads or your dynamic forces are going to be. So in my experience, it's been stopped down, interestingly. Yeah.
Okay. All right. Excellent. Thank you. All right. A couple more. This is a question for Dave's alter ego, David. I've heard about that alter ego. I have Pro Stars that are getting exceedingly hot. I'm not finding any electrical issues. Could this be the brake? And if so, can I use a screwdriver to check that its magnetism is still working?
Shane, evidently you sat through my class and you've met the two of us, but where you landed, Eric? You met me too? But anyway, to get back to the question is, more than likely that is your problem because a motor, the ProStar is getting hot. There's not a lot to a ProStar. If I was gambling that more than likely your diodes on your reversing contactor has went out, you need to replace the diodes. But to answer your question specifically is, I'm going to tell you that you can't do that because of the, you're actually inside of a motor using, with the voltage turned on. But common sense will tell you that if the magnetics is actually working, that it will suck a screwdriver over to it. But if you are on the inside, really be careful because we recommend that make sure that the motor's turned off, locked out and tagged out before you actually take the covers off. I know that really wasn't the answer that you was wanting, but that's the safe one.
Okay, great. And
there's a couple of questions on chain lubrication. We may want to answer that. Dave may want to tackle that.
Okay, I'm just a second. Let's see. Which one? Why don't you go ahead and grab the one that you're talking about? I'm looking as well. Oh, I see.
Yeah, sure. So, Dave, on one of the questions is, do we need to lubricate the chain, or how often to lubricate the chain, and what is the ideal lubrication?
Well, that's a loaded question. I really can't tell you how often to lubricate the chain. It's an absolute that you've got to. And the reason I can't say that the frequency is because if I've got a motor and that motor's hanging in a theater in a temperature-controlled area, one time a year may be sufficient. Now, if I take that same motor and I take it to the Outer Banks of North Carolina, I may have to do it every day. So really, it's application specific on how often you lubricate. I think I can answer two questions at the same time. I think I saw another one about using a rag to wipe the. That really is not going to do a lot of good. What that's going to do is that's going to prevent rust in a dry element. Where you really need the lubrication is in between the links where they actually touch. In my class, you've sat through the folks that have sat through it to see that when a 1-ton motor, a 5/16 piece of chain, is supporting a 1-ton load, then the forces in between the links is equals or goes above the 500,000 pounds of force per square inch. So that's a tremendous amount of pressure. So lubricating just the outside of the chain is good, but it's not really what we're doing as far as protecting the chain. We really got to get the lubrication in between the links. The best way to do that is in an unloaded state. I recommend you get you a bucket or a pan of some sort, take the chain out of the motor, lay it in the bucket, and then you can take a rag and wipe down the outside of the chain to make sure that so the excess doesn't drop down on a white carpet in a ballroom.
Perfect. We have to wrap up now. We have a few more questions that need to be answered. We'll take one more from that list, and the rest are going to be responded directly by Dave or Eric, or we'll be responding in the Twitter chat. Christy, can you please go to the next slide? All right, upcoming classes. We just wanted to let some of you know, or all of you know, what's coming up in the next while here. As far as classes, we have a basic motor school that'll be held in October at LDI in Las Vegas. We have a very interesting, a few different things going on. We have a Mountain Productions Hoist Motor School going on from February to March. This will be in Pennsylvania. Motor certification, a CMET RTC motor certification by Gemini Light and Sound in November in Dallas. Tomcat U Hoist and Rigging Shop will be in March in Gatlinburg, Tennessee. And last but not least, we have a CMET RTC school going on in Honolulu, Hawaii in December, in case any of you really want to go on vacation as well. Christy, can you go ahead and Hold on one second. Christy, yes, I just want to share one more thing. In 15 minutes from now, we're going to be having our Twitter chat where we're going to kind of continue the conversation, answer a few of the questions that we weren't able to answer on this webinar. And all you need to do is use the hashtag RigSafe to talk to us there and communicate and converse. And I recommend also the tweetchat.com website is great. You can go in, put the hashtag in the box, and you can follow the whole conversation while tweeting as well. So that's it for there. Dave would like to say one more thing, and I think there was one more. Okay, no, he wanted to say one more thing. Go ahead.
The last thing I want to say is I want to put a plug in on the upcoming schools. The one at Mountain Productions, that's a week-long thing, and that's where Eric and myself come together live, if you want to call it. But if you haven't never been to a school before, that is a good one to come out to. Eric and myself, we've done this for several years together.
Yes, and
absolutely, it's a lot of fun.
No, I'm sorry. Go ahead.
No, I just said absolutely. If they can check it out, any of those are really good. But the Mountain Productions one is a lot of fun. I've enjoyed doing it for the past 5-6 years, whatever it is. It's a good time and a lot of great material.
Well, I'm going to be there this year. I'm really excited about it. I wanted to go last year and missed our big anniversary, so I'm going to go next March. So it'll be good to hear you guys present. All right, if we can go to the last slide. Yes, I just want to, again, thank everybody for coming today. As I said, Dave and Eric will be responding to those final questions we couldn't get to. And if you want to reach Dave or Eric personally, here are their email addresses for additional questions or comments. We can give you that. And also, if you're on social media, please connect with us there. We're on LinkedIn. We have a CM Entertainment Twitter handle as well as our industrial Twitter handle, CMCO Live. We're on YouTube. As I said, this recording will be posted after the fact there. We're on Facebook, LinkedIn, Google+. And before I forget, we do have one polling question we wanted to share with you all. We just wanted to get a little bit of feedback for those of you that haven't attended a class. Would you be interested in attending a CM Motor Rigging School within the next 1 to 3 months, 3 to 6 months, 6 to 12 months, or not at this time? We just always like to get feedback to see if there's any interest. And just so you know, one thing we didn't talk about is if you can't make it to any of those motor schools, I know that Dave and Eric, they have schools that are private, maybe for a specific in a specific location. But if you have a group that you'd want to have trained, you can. The best thing is always to reach out to Dave Carmack. He can tell you if one is available that you could join into if it's not listed, or possibly even organize one specific for your school or company or whatever. So we just wanted to make sure we got that out. All right, so I'm just gonna let you guys finish up the poll. If you're on an iPad, you won't be able to put your comment in, but this is great. Thank you for sharing that. I'll go ahead and close that out. And again, thank you all for coming. We're so glad that you could participate. You'll be getting a link to the recording probably by Monday at the latest. And we'd love to have your feedback on the webinar. And if there's another topic you'd love us to talk about, maybe I can twist a few arms and get these two guys back on again. So thanks so much, everyone. We hope you can join us at the Twitter chat, and let's all focus on rigging safe. Thank you. Bye-bye.